Take your laptop and phone for the day. All right. Let's get going. First of all, any questions about last night's homework in general? I know there were some tough ones. So you will see one of these again. You have to be able to, whenever they say which of the following, you have to be able to sort through G prime, G double prime, and then eventually G triple prime. So if they give you one of these, then obviously you're going to take the derivative of the one above it to see if that would work as a G prime. All right, and vice versa. If they gave you G double prime and they ask you for this one, you would take the derivative and see if it matches up. All right, so be able to work between, I call these the layers of derivatives. Original, first, second, and third. Did you check their work? All right, so we're lacking motivation today. Look good. Let's talk about inverse trig derivatives. What is an inverse function, specifically trig?
No. You didn't even put it's not on there.
Sorry. Right. What is a inverse? Before we talk about derivatives, what's an inverse trig function? Well, how do you find an inverse in general? Y equals x. Before we even talk about trig, we'll back up. How do you find the inverse of this function? Okay.
Switch x and y and solve for y.
I'm going to stop you right there. You've been taught this before, okay? And the teachers may have had you do the process of solving for y, but would you agree at this point in blue, you've found the inverse? Yes or no? As soon as you switch x and y, you've switched what? Now, I don't know how much you really looked into this, but you've automatically switched the domains and ranges right there. The domains and ranges have switched. If you solve for y, that was just to graph it to see what it looked like. But at that point, you've taken the inverse, haven't you? Yes?
Yes.
Awesome. So that's how you find an inverse. So if I say y equals sine of x, then x equals sine of y is the inverse. Do you agree? Now, I could, I will. It's gonna get a little shady here. I'm going to put the first rule up there and let you write it down. And I'm going to prove this one. The derivative of sine inverse of u. What's u again? What is u? A function of x. Good. It's a function. So we need the chain rule. Every rule we learn from here on out is going to be written as the chain rule to allow for it to be something other than x on the inside, like 5x, 10x, radical x. We could go a lot of different directions. That's why I hesitated a little bit because I don't know how much in depth you guys got last year with inverse trig functions. Do you remember that? Did you write it as sine inverse of x? Did you write it like that? Did you write it as y equals, have you seen this? Arc sine of x? Have you seen that? And then if you write it with capital A, capital arc sine, it's something different. Did you talk about that?
No.
Okay. I don't have time today, and I don't want to confuse you. So we're just going to hit the main ideas today, all right? If we want to get in depth later, we can. Okay, I'm kind of feeling out what you guys know here. Have you learned what an invertible function is? A function is invertible if, do you know?
It passes the vertical line test.
What passes the vertical line test?
The inverse.
Yes. You switch x and y. Okay, so you create an inverse, and the inverse is a function. Ready? Y equals x squared. Switch x and y. X equals y squared. So let's solve for y. Square root both sides, plus or minus. Plus or minus the square root of x. Positive square root of x, negative square root of x. Does that pass the vertical line test? No. So y equals x squared is not an invertible function. I can find its inverse, but its inverse is not a function. Make sense? All right. So that has to do with the whole capital A arc sign and lowercase a arc sign, is whether it's invertible or not. Because what does sine of x look like? What does sine inverse look like? I should have done arc sine for Halloween. Maybe.
Just been one of those like dazzling block.
Yeah.
There you go.
Three-dimensional arc sine. Translate. Reflected. I like it. We're going nowhere. All right. I want to prove this one. Now, before I do, when I said if you're a memorizer, you're going to like this. Because guess what? If I said find the derivative of sine inverse of 2x, you use this template. Watch how easy this is. This template says take 1 over the square root of 1 minus 2x squared. 2x squared. What is 2x squared? 2x times 2x. 4x squared. Times, what's this du dx? In our problem, what's du dx? It's the derivative of the inside, right? It's the derivative of the inside of sine inverse. Times 2. Done. Done. 2 over the square root of 1 minus 4x squared. That is the derivative of sine inverse of 2x. If we trust this template right here. If we trust the template. And by your moods today, I don't think you have any point in arguing with that. You guys are too tired to argue with that. Do you see why I'm saying this is easy if you know the template? You have to memorize that. Okay? If I were an ambitious AP Calculus student, I would be like, where does that come from? Why the heck is the derivative of sine inverse of something involving a fraction and a square root? Why isn't it trig? Would you agree with that? Did anyone think that? A couple of you. Okay. So this is worth me. I'm going to prove this one, and then I bet you guys are okay. That's enough. Like, I'll just trust you from here on out. All right. So here we go. I'm taking the derivative of sine inverse of u, and I want to end up with this. So remember on your last quiz how we started off with the derivative of cotangent of x, and we wrote it as sine, cosine over sine, did the quotient rule, all that kind of stuff. We're going to do something similar here, only we're going to start off with the derivative of sine inverse, and it's going to end up being this. Okay? So the derivative of sine inverse of u. And I'm just going to call it x. I'm not going to make it composite yet. You'll see where that comes into play. Well, if y equals sine of x is the regular sine of x function, I want to find first the inverse of sine and then take the derivative of the inverse of sine. What's the inverse of sine of x? Well, Kylie told us to find the inverse, switch x and y. And again, I'm only doing this process once. This is a proof. This is not something I want you to do every time. What are you going to do when you take the derivative? Use the template. Done. Okay? But I feel like if I'm going to be a good teacher every once in a while, I need to show you where this comes from. All right? So here we go. That's the inverse. I want to take the derivative of the inverse. Ready? What's the derivative of the left side? With respect to x? 1. What's the derivative of sine of y? Careful. Cosine y times dy dx. Ooh, an implicit derivative. Makes sense. We just did implicit differentiation, doesn't it? So dy dx is 1 over the cosine of y. Do you agree? But wait, there's more. I know an identity. Sine squared y plus cosine squared y equals 1. Yes? If I want to substitute, I want to solve for y, cosine squared y equals 1 minus sine squared y. Square root both sides. Cosine of y equals plus or minus the square root of 1 minus sine squared y. Are you with me so far? What is the cosine of y? Plus or minus? Isn't sine squared y really sine of y times sine of y? Right? What's sine of y? X. Back from the inverse function. So what can I plug in for sine of y? X. And that's where it comes from. All right? Make sense? Kind of ugly, but that's where it comes from.
What happened to the plus or minus?
I should have written it, except for it gets into the. I didn't write it because it gets into the conversation of convertibility, and so nope, other side. Did anyone notice this here? What does that mean? Absolute value of u is less than 1. Write that as an inequality for me, a compound inequality. If the absolute value of u is less than 1. Cool.
U is greater than 0 but less than 1. Or 0 is less than u.
Not quite. I like that part. Dom?
-1 is less than u, which is great. This is less than 1.
So if I say, yeah, thank you. Absolute value of u is less than 1. What number? Okay, let's think about this. What if I plug in -3/4? What's the absolute value of -3/4? 3/4. Is that less than 1? Yeah. How about -0.9999? Yeah. So any number for u could be like from -1 to 1. Where this would be a true inequality statement, right? So wait a minute. -1 to 1, they put in for u, which in the most simple case is x, correct? What's x? The input. What's the domain? Y equals sine of x. Domain. All real. What's the range? What's the range of sine of x? -1 and 1. If we're finding the inverse function, doesn't it make sense that the range is now the domain of the inverse? Right? So why no equal to then? Here the range was equal. Sine could go up to 1. Sine could go down to -1. You're jealous, I know. Just imagine me at a school dance, okay? Because that's my life. Guys, this is lifelong relationships get built on dance moves like this, okay? Don, what do you think?
It can't be 1 because if it's 1 minus 1 squared on the bottom, you have to be divisible by 0.
Okay. And what does that mean?
It's
If the derivative is 0
it's
or division by 0?
undefined.
Yeah, good. Ready? As soon as that inverse function gets graphed like this, once the derivative gets up to this point, which was the max on sine, it's a far right point on sine inverse, vertical tangent. No derivative, so don't include that in the domain. Did that make any sense? Here's sine inverse. Okay, let's stop it. Let's say we stop it right here and right here. Don't include those points. Why? Vertical tangent. Here, slope's okay, slope's okay, slope's okay. Here, vertical slope. When u equals 1, it was a max on sine of x. It's a far right point on sine inverse, and it's a vertical tangent because up here at sine, it was a horizontal tangent. Does this make sense? We could go a lot further, but I think that's good for now, okay? Do I expect you to write the domain restrictions on these all the time? Not yet. Not yet. They get kind of ugly. I at least wanted to address where it comes from. Does that make sense? The domain of the original becomes the range of the new, and vice versa. The range of the original becomes the domain of the new, inverse. Okay. So, Luke, to answer your question, we don't include both the plus and the minus because we want it to remain invertible. If we included both, it wouldn't pass that vertical line test. So we actually restrict the domain. We restrict the domain on what's called the principal branch. Did you hear those words last year? Principal branch? Good talk. All right. Is that 8 times x squared, or is that 8x being squared? 8 times x squared, or else there would need to be parentheses. So let's go ahead and use our template. How comfortable are you guys with it? I feel like you're not really comfortable with inverse restricted functions. Is that true? Like if I say, what's the sine inverse of pi over 2? I'm sorry, sine inverse, I gave it away. Sine inverse of 1. Can you answer this question? What's the sine of pi over 2? Now, I don't know why we don't explain it like this more often. But when you guys, I'm getting way off topic. I'm sorry. I kind of backpedal when I know that I'm reaching a point of confusion, and I go back to the next thing I know that you know. All right, and we'll work from there. Is that fair? I'm sorry. I'm all over the place because of that. I'm trying to feel out. Okay, I don't quite get this, so I'll go back to this. You know y equals sine of x. If I said find the inverse, okay, Kylie said switch x and y. Switch x and y. Now, what if I said, okay, solve for y? What would you do? Because if we wanted to graph it, we switch x and y and we solve for y. How do you get rid of this sign? It's sine of y. How do you get rid of a sign?
Times my inverse.
Divide. You might think it's times, but we sine inverse both sides, and it's not technically multiplication. It's like saying, okay, x squared, y equals x squared, or even better, y squared equals x. How do you get y by itself? You wouldn't quite say multiply by the square root on both sides, right? You'd say take the square root of both sides. It's an operation of its own. In the same way, and I wish the teachers, I wish we did this more often, where we actually showed this process. I don't know how many of you guys have seen this process. Did you see how I wrote it in red? I took the sine inverse of both sides. Yes? Sine inverse of x is over here. What is the sine inverse of sine of y? Well, what's the square root of y squared? Y, right? What's the sine inverse of sine of y? Well, you did that process to get rid of sine. Doesn't a sine inverse get rid of sine? So what's left on the right side? A y. Y equals sine inverse x. Another point I know you know. Ready? Right triangle trigonometry. Back to geometry. Oh, where's gravity? No, that's it. Different song. All right. 3/7 theta. How would you solve for angle theta? Cool.
Inverse tangent of 3/7.
Now wait. Tangent of theta equals 3/7. Do you agree? And actually, I'm going to redo this because I'm emphasizing. My CPUs weren't so high that would have worked. I math, I promise. All right. All right, theta. Now it's going to be opposite hypotenuse. Sine of theta equals 3/7. True statement, false statement? True statement. How do I get theta? Now, here's the deal. I don't know what class you learned this other than geometry, but right away, a lot of teachers will do this. Just type in sine inverse. Just type in sine inverse of 3/7. Correct? Just type in. Well, technically, you had to get rid of sine because we want theta by itself. We had to take the sine inverse of both sides. Sine inverse gets rid of a sine, we're left with theta, and then you calculate sine inverse of 3/7. I know it's picky, but do you see the importance there? Why is that important? Well, because up here, now when you don't have any calculations that can be typed in, you have to understand symbolically what's happening. Okay. Well, if you can answer, okay, so now we're back to where we started. If y equals sine of x, if I gave you this problem, what's the sine of pi over 2? What's the sine of pi over 2? 1. Sine inverse both sides. What happens when you sine inverse a sine? What's left? So the sine inverse of what is pi over 2? 1. The sine inverse of 1 equals pi over 2. If the sine of pi over 2 is 1, and you switch the domains and ranges, then the sine inverse of 1 is pi over 2. Correct? Very important that you understand that. Okay? Back to the story. Where'd the triangles come from? Sorry. Come on, isn't that kind of interesting?
Yeah.
You're just appeasing me now. Caden, a little bit interesting?
No.
Thank you, Caden. You got this. I got this. Template. Just like they make templates for a lot of things, right? Detentions. All sorts of things. All right. Here's your template for sine inverse derivative. Sine inverse derivative. It's 1 over the square root of 1 minus u squared. The u changes with each problem. What is our u? 8x squared. What's our du dx? 16x, thank you. Put that up top. What is 8x squared squared? 64x to the... Good. Can I just square root each number and subtract? Some of you tried stuff like that on the quiz. Can I just say that's the square root of 1 minus the square root of 64x to the 4th? And just say, okay, that's 1 minus 8x squared. Legal? Illegal? Illegal. And I want to I guess one of my goals as a teacher is to typically help you guys to not just memorize rules, but to understand why things work. And if you feel like that is legal, test it with easy numbers. What's the square root of 16 minus 9? Bad example. I meant to say 25 minus 16. 25 minus 16. 25 minus 16. What should the answer be? 3. 25 minus 16 is 9. Square root of 9 is 3. So I know that answer. And then so if I'm on a quiz or a test and I'm like, oh, I just did that. I don't know if it feels right. Try it. What's the square root of 25? What's the square root of 16? That's 1. Is that right? No. Illegal. So be able to test it and model it with numbers if you're confused. That's our final answer. That's our final answer. All right. The process is pretty easy. Students, the biggest mistake is students feel like they're not doing enough. They're like, that didn't feel like I just took a derivative. I'm going to take the derivative of that. Okay? And it's like, oh my goodness, no, like you don't get it. That's the derivative of that. Done. Okay? Last one for today. Write down the derivative of tangent inverse of u. This is a new template to memorize. So we have sine inverse of u, we have tangent inverse of u. Good lunch today, man?
Same thing every day.
What do you have?
Ham sandwich, mustard, green peppers, bag of chips, and Welch's gummies.
Welch's what?
Welch's like fruit gummies.
Oh, no.
I don't have chips.
Do you have cheese on this?
No.
Cheese?
Put cheese on it.
It's just
It's just
Right?
Yeah, it's
It's
just a ham sandwich.
I don't like
Hey, let's not judge his lunch. The man likes what he likes.
Mustard is so bad.
All right, does everyone have 1 over 1 plus u squared times d dx? Awesome. I don't want to get into it, but what's the range of regular tangent? Right? What's the range? Do you agree? So that's why there's no domain restriction on this one. Okay? Ooh, I lied. Last one, secant inverse. Oh, Dom, I'm glad someone asked. Why the heck's he doing sine inversion? Tangent inversion? Secant inversion? Caden's getting angry up here. Caden, I'm sorry you despise calc so much.
It's alright. It's just math in general. Don't take it personal.
I kind of will. My life is math. Feels like sometimes. College, it really felt like it because I would take my senior year. I had 5 senior level math classes.
Disgusting.
And then I also worked at Kent State in the tutoring and testing center, so I tutored math all day when I wasn't taking classes. And I would go home and have to do all the homework from the classes.
How'd you escape from math?
How did I escape?
Yeah, from math.
What did
What'd you do to like get away from math?
Oh, I worked at Red Robin on the weekends. Reading tables.
That's why.
Yum. All you have to do is plug it into the template. Okay. Quick question, because you're gonna, if you look in the back of the book at some answers, you're gonna see some cancellations. When is it okay to take the absolute value off of u? For example, what if this is x squared inside of u? Can x squared ever be negative? So when you take the absolute value of x squared, is it necessary? No, because it's already positive. It's always positive. You don't need the absolute value. So what's the du dx going to be if it was x squared to start? 2x. Oh, that x and one of those x's can cancel. If you see the cancellation, that's where it comes from. All right? Make sense?
Yes.
I'd say you guys had a pretty decent day's work. Let's Yes?
Show us the tabs.
No, you
Show us the tabs.
We'll forget it.
I'll show you guys on Monday. I'll show you the tabs on Monday.
No, he's gonna restart. He's gonna
Can't see him before the weekend?
Yeah, see what happens if you don't do any homework.
Is that a threat?
Who said literally nothing? I used to like you guys.
What if he changes it? Nah. Sometimes he changes it. Don't put it on the whole page now. And all the people that left don't know wait. Make them watch.
Yeah, put like a couple extra problems on the page.
The actual homework is.
Just put like 50 on the whole page for people that left.
Yeah, that'll teach them.
Hell yeah.
Bonus content. You stay an extra 5 minutes, you get to see the tabs. Let's see some tabs. Yep, you gotta back up, Casey. What does? It does stress me out. I just kind of deal with it. I have.
My mom, it was, IQ